Hey everybody, this is Gregory from Dapp University, and today we're going to be talking about gas on the Ethereum network. This will be a two-part video. The first part today we'll talk about a conceptual overview of what gas is and why we use it and how it works, along with a few code examples. And in the second part, we'll see how deep the rabbit hole actually goes. We'll see all of the operations that go into how much gas transaction uses on the Ethereum network, and we'll take a deeper look at why gas matters when you're writing smart contracts in Solidity for the Ethereum network. So be sure to subscribe to the channel and turn on notifications with the bell below so you can see that second video when it comes out. And the channel is growing, so I'm going to start making some videos faster, and that next video should be out just in a couple days. So let's take a look at gas. What is gas and why do we have it? So I've got some notes here that I've created in a GitHub repository on the Dapp University GitHub. I'll put a link to this down in the description of the video below so that you can get these notes if you'd like to. So why does Ethereum use gas? Well, the Ethereum blockchain is a peer-to-peer network, which basically means that it's crowdsourcing all of its computational power. So the Ethereum blockchain is a network that's made up of nodes, computers, that all talk to one another. And some of these nodes opt into the mining process. They actually opt into the process of creating transactions and writing data to the database, which is essentially the public ledger on the blockchain. Now, these nodes basically agree to use their resources, their computational resources, to help run the blockchain. And in return, they get a chance to earn some Ethereum for doing this. Now, I say a chance because anytime a transaction is mined on the blockchain, the miners actually compete to win this transaction. And it's the winning miner who's actually awarded the Ethereum that was paid to create the transaction. Now, I should mention that this only happens when we're trying to write data to the blockchain. Writing data costs gas on Ethereum because these mining nodes have to perform this mining process, but reading data from the blockchain is completely free. And if we were just going to fetch a list of information, we wouldn't have to pay anything. And that's why we have gas on the Ethereum network. The Ethereum network is decentralized. It is made up of peers, of nodes that talk to one another. It's not a centralized system where an organization would normally have to pay money for server costs. They would have to pay to keep up a database. Instead, everyone who participates in replacing these jobs, replacing these roles on the blockchain is compensated by users who are paying to complete transactions on the blockchain. So let's look at some kind of concepts that are surrounding gas. And these are kind of like vocabulary words that are thrown out there when you're developing applications on Ethereum, or you're just using a decentralized application on the Ethereum network. Maybe you're participating in an ICO or you're using a Dapp. You might have seen these kinds of things before. These are gas limit, and gas price. And I'll also talk about transaction cost, but we'll focus on these three first. So gas, it's just a unit. And it's contrary to what some people think, it's not actually a unit of Ethereum. It's just a unit in and of itself. And it's used to describe how much a transaction is going to cost. So let's take a simple example to say, I want to send you 1 Ethereum from my account. And let's just say that that transaction is going to cost 1 gas. Well, that does not mean I have to pay 1 Ethereum to send you 1 Ethereum. That just means I have to pay 1 unit of gas to send that to you. So what is gas? Well, it's just an abstract unit in that case. So think about gas like you would be putting gas in your car. If you go to a gas station, you're going to pay a gas price. You're going to pay for some unit of gas. This unit of gas is usually a gallon or a liter, depending on whatever system you use. So you can kind of think about gas as 1 gallon of gas or 1 liter of gas. Those are just kind of abstract units that don't actually correspond to money, right? They're just a unit. So if I were going to send you 1 Ethereum and I have to pay 1 unit of gas to do so, we would factor in the gas price to determine how much Ethereum that would actually cost. Now let's say that, sending you 1 Ethereum cost 1 unit of gas, and the gas price is 0.01 Ether. If I'm just going to pay 1 unit of gas at 0.01 Ether per unit of gas, that's just 0.01 Ether for that entire transaction. So sending you 1 Ether might cost 1% of that amount in this very simple example. Now, it'll get more complicated than that, but I wanted to just kind of introduce you to that concept right here. Now, don't just take it from me about these concepts. I'll actually show you in the Ethereum yellow paper that these concepts are clearly defined, and you can read about them yourself. Now, some of this can get kind of heady, so do not fear if there are some scary looking things in here. Let's look at gas price. So right, you can see these values are defined in the yellow paper. So you see gas price is a scalar value equal to the number of Wei to be paid per unit of gas for all computation costs incurred as a result of the execution of this transaction. And it gives you the variables that it's using in the equation that it's talking about. Now, we'll talk about Wei here in a second. But yeah, I've tried to distill these concepts down to a little more layman's terms. But yeah, feel free to poke around in the Ethereum yellow paper. It's very interesting. And like I said, you can go really deep really quickly. So don't fear if there are some things that are a little above your head. That's okay. So let's take a look at how gas kind of works in the context of a smart contract and how we would use gas if we were going to interact with this smart contract on the blockchain. Now I'm using Remix, which is a browser-based IDE put out by Ethereum. And I have a smart contract here that I've written. This is an election smart contract that basically allows users to vote in an election for different candidates. And I have a 2-hour tutorial where I walk you through step-by-step how to use this smart contract to build a full decentralized application. So if you want to check that out, I'll put a link down in the description below. In that tutorial, I also show you how to set up your local environment for Ethereum development, for decentralized application development. So it shows you how to set everything up to make this work locally on your machine without using some sort of browser-based IDE like Remix. But Remix is pretty nice for something like this, so that's what I'm going to use here. So let's actually create some transactions with Ethereum on the blockchain with this smart contract. And we'll do that in 2 places. First, we'll create a transaction just by publishing this smart contract to the blockchain. Now remember, anytime we write information to the blockchain, it's going to cost gas. And whenever we deploy our smart contract, we are writing new data to the blockchain, and that will cost gas. So we can see that we have our constructor function here in the smart contract. This may look new to you if you're new to smart contract development, but you can get a more in-depth understanding of this by watching my other tutorials on smart contract development. But basically know that this is our constructor function that is the same name as the smart contract itself. And this is the function that is going to get run whenever we deploy our smart contract. And it's basically just adding some candidates that will be running in our election. So let's go ahead and deploy this smart contract to the blockchain. Normally I would use like the JavaScript virtual machine if I was going to just, debug the smart contract, or if I was just developing this smart contract. This basically allows me to run it virtually inside this browser. But I'm actually going to deploy it to a test Ethereum network. This won't be the mainnet Ethereum, so I'm not actually going to be using like real Ethereum cryptocurrency to run this transaction, but I am going to deploy it to the test network, which you need test Ethereum for. Now, it's not worth real Ethereum, but you still need Ethereum in your wallet to perform this transaction. In order to do this, like I said, I've clicked at Inject Web3 to deploy it to the test network. So I'm going to actually publish a smart contract and create a transaction and pay some gas. So let's do that now. When I do that, you will see a confirmation pop up. Now, this confirmation comes from the MetaMask extension in Chrome, as you can see this little fox right here. Now, MetaMask is basically a Chrome plugin that turns your web browser into a blockchain browser. It basically allows you to use the blockchain with your browser, which is currently a functionality that most web browsers lack. So anytime I want to use the blockchain, I have to have an account that's connected to the Ethereum blockchain, and that's what MetaMask keeps track of. And if I'm going to create transactions on the Ethereum network, I need Ethereum in my wallet, which I do here. I have 1.99 fake Ethereum because this is the test network. That would normally be equal to this much USD right now. And so you can see that I need to confirm that I want to send this transaction. And we can see some of the terms that I talked about: gas limit, gas price, and this will be the actual transaction fee, which I mentioned in my notes a second ago. And we can see that this transaction, if I'm just going to say, 1 unit of whey here, would equal to 0.47 US dollars, 47 cents. So let's go ahead and submit that. You can see this is pending. We'll wait for this to go through. All right, so we have deployed our smart contract to the blockchain, and we can see a transaction receipt here. We can see details about that. We can see the gas and the transaction cost. So let's look at some of these details a little further. In order to do that, let's create some more transactions on the blockchain with our voting function. Now, this is a function in our smart contract that basically allows an account to vote for one of the candidates in the election. And this function is going to take one argument. It'll be, just an integer value of the candidate ID. And I only have 2 candidates in this election, candidate 1 and candidate 2. And each of these will just have an ID corresponding to, their number. So candidate 1 will have an ID of 1, and candidate 2 will have an ID of 2. And in Remix, I have, a list of all my functions over here that I can use to interact with the smart contract. And I know that this function here is going to create a transaction because it's red, just like the create function here. So if I want to vote, I can simply say that I want to vote for candidate number 1 with this account right here in my accounts list. This is the account that I'm connected to the blockchain with. And let's actually vote. Again, we see this confirmation pop up. So let's look at the concepts related to gas, as they pertain to calling this vote function. And, there's a few terms here. There's, gas, there's the gas limit, the gas price, and, also the total transaction cost. So if we're thinking about gas, you can think about gas kind of in 2 ways. In one way, gas is just sort of the general idea that, making transactions on the Ethereum network costs gas, and gas is kind of what powers the Ethereum network. Now, that's one way to think about it. The other way to think about it is gas as a unit. And gas is sort of just this abstract unit. You can think about it like the amount of gas that you would put in your car at a gas station. Like I said earlier, normally you would say I'm putting 10 gallons of gas or 10 liters of gas into my car. Well, in a transaction, you could think about that similarly. I'm going to put just 10 gas in my car. And at a gas station, you would pay, let's just say, $3 for a gallon of gas. In a similar way, you would pay, just for easy numbers, let's just say you would pay 0.01 Ether, which would be way too much, but just for example, you'd pay 0.01 Ether for 1 unit of gas. It's kind of a similar way that you would think about gas on the Ethereum network, just like a unit of gas that would you put in your car. Now, that being said, I mean, we can see, gas as a unit here when we talk about the gas limit of this transaction. Just units, that means this is 64,074 units of gas. Multiply that by the gas price. That means the maximum, transaction fee would be only, 6 cents in US dollar, or 0.64 or 0.000064 Ethereum. Now let's actually talk about the units of Ethereum as well. We see this here. This is a larger denomination of Wei, and Ethereum can be broken down into smaller denominations, and we can see the conversions here on etherconverter.online. And I would just fill this in with 1 Ether. So we can see how 1 Ether is broken down to the smallest unit, which is Wei. This is the actual units that we use inside of our smart contracts when we're sending Ether and when we're calculating transaction costs and things like that. And this can just be, multiplied by larger units to eventually have more meaningful representations of Ether and how it can be subdivided. So yeah, you can see this is Wei, this is Kilowei, which has other names, Megawei, Gigawei. This is now Micro Ether, Milli Ether, 1 Ether, and so on and so forth. So if we go back to Remix and we try to make our transaction, we can see that this is gas price is going to be expressed in Gigawei. And so if we multiply the number of units of gas by the Gigawei value, then that turns into this much Ethereum. And MetaMask has conveniently converted that to US dollar for us. Now let's talk about, gas limit and why we use it and why it's important. So this is really a limit for, the amount of Ethereum that could possibly be required to complete your transaction on the blockchain. And, some people get scared by saying, oh, I might pay, this much Ether when I only need to pay, a fraction of that to, complete my transaction. Well, I don't want to do that. But really, this is just a safety net, especially when you're developing smart contracts. So imagine if a function that you were calling in your smart contract had an infinite loop. Well, if you called that and you had no gas limit, then this function could drain all of the Ethereum out of your wallet. So if you had 10 Ether in your wallet and you wanted to, create a transaction that you expected to be, this small, 0.000064 Ethereum, and it just went into an infinite loop, it would drain everything out of your wallet. So that's why we have something like a gas limit. So something like that can't happen. This gas limit is definitely not going to equal, typically the amount of gas that you'll pay for the transaction. Usually it's much lower. So any gas, that is not used will be returned back to your wallet. So basically this is saying I'm going to provision this many units of gas, times the gas price is going to equal about this many Ether. I'm going to provision, potentially this much Ether, which corresponds to 6 cents in US dollar for this transaction. I say if it costs this much, that's okay, but I expect it to cost way less than this. That's what the gas limit is. And if it doesn't use all of that, which it probably won't, it will refund that amount back into your wallet. Now let's talk about gas price a little more. Now I said, you can think about gas price like it's just, the price of gas, like at a gas station. If I was going to pay $3 for a gallon of gas in the United States, then it's, going to cost $3 per gallon. Here, it's going to cost, 1 gigaway per unit of gas. So if it's this many units times this many gigaway, it equals, this is how much it would cost to fill up our tank or, complete the transaction. Now, I will say this. Gas price is going to have a bearing on how fast your transaction is completed on the blockchain. And, typically a higher gas price means that your transaction will be processed faster. And here's why. When, the miners receive multiple transaction requests in the same block, then, the transactions, they can be sorted by the gas price. And this means that the higher gas price transactions, they're going to get mined first because it brings, more money to the miner. And that doesn't necessarily mean you need to just, raise this thing up like crazy. You don't need to say, I'm going to do 1,000, gigaway just to ensure that my transaction will be processed quickly. That's kind of absurd, but it does mean that the higher you go, the faster it's probably going to happen. And you can take a look at this over at the Ethereum gas station. You can visit that here at ethgasstation.info. And we'll see, this kind of gives you, current status on the Ethereum network. We can see over here recommended gas prices based on current network conditions. So this is gas price in gigaway. So basically, if you provision a gas price of 1, then you can expect a transaction that's less than 30 minutes. If you provision a gas price of 3, you can expect less than 5 minutes. And if you provision 12, it's less than 2 minutes. And you can also see a graph here of confirmation time by gas price. So if it's less than 1, it's this many minutes, and so on and so forth. So now we can see, the maximum amount of gas that we would possibly pay for this transaction. We can see the price. Let's just increase this to try to get a faster transaction. We'll just increase the gas price to 3 gigaway, which means our maximum transaction fee would be 18 cents. Now, we've used all these metrics so far to, compute a maximum theoretical cost for our transaction. Let's go ahead and vote and see how much we actually paid to vote. Now, just to show you the difference between the gas limit and the actual gas used, I'm going to just paste in the maximum gas limit that this will allow us to use. We'll still say the gas price is 3. Let's just do 1 for easy math. I'm going to say this is the maximum amount of gas we want to pay. We're willing to pay 1 gigaway per unit of gas. So at most, our transaction is going to cost us $4.14. But the actual cost is going to be much less than that, and that's what we'll observe here in a second. So let's submit our vote. We can see our vote is pending here, so we'll wait for that transaction to complete. All right, so this is finished. Let's take a look at the details here. Let's actually pull this up a little bit. So this is our transaction receipt for the transaction that we just created on the test network. And we can see that this is the gas limit that we provisioned for our transaction. And this is the actual amount of gas that it cost. So, we said we were willing to pay this many units of gas, and we thought that we were willing to pay this many units of gas, but we actually only had to pay this much. And you can see this number is much less than the actual gas paid. We can see more details about this transaction by using a blockchain explorer like etherscan.io. And remember, I actually published the smart contract to the test network. So that's what we're looking at here. This is a blockchain explorer for the test network. And we can see this is the gas limit. This is the actual amount of gas used by the transaction. All right, so yeah, you can see that that actual gas amount used by the transaction was much smaller than the gas limit. And these are just units, so let's see what our actual transaction cost us. This was the amount of ether that was used by the transaction. That amount is multiplied by the gas used by the gas price to give us this amount of ether. Let's convert this to US dollar. Seems like that didn't quite work here. So we can just see on coinmarketcap.com that Ethereum is $932. Go back and see, copy this value. This is how much gas we actually used. So we'll paste that value in and we'll multiply that by 932. That's equal to about 6 cents, 6 cents in US dollar. So instead of our possible transaction fee, what we saw a minute ago was like $5 maybe. This was the maximum gas limit that it would allow us to use. It was, way less than that. So I hope a lot of that made sense. Again, gas is kind of a misunderstood concept on Ethereum and, with Ethereum development and people who are just using decentralized applications. So if anything was still unclear, feel free to leave a comment in the section below and I'll try to address those concerns specifically or those questions specifically. Now, understanding gas is very important when you're developing smart contracts and dApps. With Ethereum, because you want your Solidity code to be very efficient. You want to minimize the amount of gas that's required to run your code. And in order to do this, you also kind of have to understand the operations your code is executing and understand the actual cost of each operation. And that's exactly what I'm going to talk about in the next video. We'll take a more in-depth look at the individual operations that make up transactions. We'll talk about the opcodes at the Ethereum virtual machine level, and we'll also dig in more to the Ethereum yellow paper that we saw a minute ago to see how all this works. And we're really kind of going to see how deep the rabbit hole goes. So be sure to subscribe to the channel and turn on notifications with the little bell below your video so that you can see that video when it comes out. And until then, thanks for watching Dapp University.